Hey, good morning, Pirates. Real quick screencast discussing the answers for our Forces in Motion FET simulator activity. You can see here I have worked through it, and I'm going to talk about each question. The first question, how does the friction screen differ from the net forces in motion screen? The big differences are the friction screen, the objects are being slid across the floor, and you have a friction slider. The screen with friction also includes a net force arrow. The other screens do not have that net force arrow, but they do also have carts or a skateboard with wheels, so you have a different kind of friction. You have rolling friction instead of sliding friction. So if you look here, you can see there is no cart or anything involved. But if we go to, I lost it. If we go to the motion simulator, we're dealing with a skateboard, and the tug of war or net force, you have a cart with wheels. Something new you discovered, answers will vary. Just, show evidence that you've played with the simulators and discovered some new concept. Number 2 says, imagine your friend is trying to move a box using your bell work and what you learned exploring. Draw arrows to predict what might happen. Well, if Sam is not pushing, there'll be no arrows. If Sam is pushing and the box is not moving, then your applied force arrow would be equal to your friction force arrow, and they would cancel each other out, so there's no movement. You have a net force of 0, or a sum of forces 0. And then if he's pushing and the box is moving, then the applied force would be greater than the resistance or the friction force, causing movement to the right. And so here you're just going to have reflected on what you did up here in your predictions. Letter C, what do you notice about the similarities and differences between the applied force arrow and the friction force arrow in each situation? The applied force arrow has to be larger than the friction force arrow for the box to move. As you make the applied force arrow bigger in any situation, then the net force arrow or the sum of forces arrow will grow in that direction. Something else that maybe you observed. Number 3, how can you make the friction force more? A couple ways you could do this. One of them is just to slide the friction slider, or you can add mass to the object. So if you just change the friction here from none to lots, you're changing the friction force. And we set this up, notice that if I just add mass, my friction force increases. If I take mass away, my friction force decreases. And changing the slider. Page 2. In your own words, describe friction force. Friction is force created by the surface between two objects when one object is moving or sliding past the other. And so the smoothness of the surfaces, lubrication, things like that can change the amount of the force. Describe applied force. Applied force is just how hard you're pushing or pulling in a situation. Number 5, have Sam try to move the refrigerator. What's the difference from pushing the box? And so Sam not pushing, there's no sum of force arrows. Sam pushing but the refrigerator not moving, there's no sum of force arrow. Opposing forces are canceled out, so you would have an applied force and a friction force. And then for Sam to push and the refrigerator to move, you would have a sum of forces arrow going in the direction of the push. The difference from pushing the box, you have to reduce the friction to get the refrigerator to move. Otherwise, there's not enough force in the force slider to move the refrigerator as its default setting. So were you able to move the refrigerator? Initially, no. What would you have to change? You have to reduce the friction slider, lower the friction. Try pushing other things. You can even stack them. What have you discovered? Increasing the mass also increases the friction force and then requires more applied force to move an object. And so once again, if I add objects, my friction force increases. And that changes my sum of force arrow. So I would have to increase my sum of force, or excuse me, my applied force in order for a sum of force arrow to appear when I increase the mass. Page 3. Can you find different ways to make the sum of forces arrow change? List at least 3. So ways to make the sum of force arrows change are things like adding and subtracting mass, changing the friction, change the direction of applied force, change the magnitude of applied force. So those would all work to change that sum of force arrow. In your own words, what is net force? Net force is just the sum of forces in a situation. And so in our simulator, the net force is indicated by the arrow called sum of forces. Some ways you can change the speed. Very similar answer to number 7a. Adding and subtracting the mass would change the speed, changing the friction, changing the direction of the applied force, changing the magnitude of the applied force. All of those things would change the speed in a scenario. What general statement can you make about the relationship between net force and how fast an object changes its speed? And so the greater the net force, the faster an object will accelerate. That's how they're related, and that's directly related to Newton's second law. Final question, true or false, if an object is moving to the right and slowing down, then the net force on the object is directed towards the left. This is true, and we could demonstrate that if I reset this and I get this thing going. And then I stop pushing on it, so now it's slowing down. Notice the net force is pointing to the other direction, to the left in this case. That's it. When you have them all completed, edit. Please be sure to ask if you have questions, shoot me an email, and I hope you enjoyed the simulator. Have a good day.